All right, hello everyone. My name is Eli Walton, and today I'm going to be talking about chemistry of drugs and drinking water. So this is like an important topic because some scientists have discovered different traces of amounts of ferro, uh, ferromacutic, macuticals in drinking water systems around the world. And throughout this presentation, I'm going just to be talking about the history behind the chemistry of it. So for the introduction, so most people might assume drinking water is completely free of medications, but that's not the case. Some scientists have found different traces of amounts of drugs in rivers, lakes, groundwater, and even drinking water supplies as well. Drugs include antibiotics, antidepressants, hormones, and pain relievers. Although the concentrations are very small, scientists are studying more long-term exposure into more public implications and growing environment concerns. For some historical development. In the late 20th century, uh, they started to discover scientists did not have enough equipment to detect some of the chemicals that were entering the water. Environmental scientist named John P. Giesing, according to Chandler et al., helped study containments in water and how they were contaminated into the ecosystem and into our environment. Um, these discoveries change and they change the scientists' views of drinking water safely. How drugs enter the water systems. So there are different ways for um, these drugs to enter the water systems. So when people take medications, they usually don't take all of the medications, and if they don't do that, they just dispose it into the toilet, and it goes to the sewers, which can affect like the fish in the water, and it goes down the toilets and sinks and affects the fish in the water and affects all different types of animals in the water as well. Hospitals release these different waste in in wastewater systems as well. Um, they usually try and test the farm animals to get treated to see if these medications are infecting them, and this is all in the website of Chandler et al. Chemistry behind contamination. So the chemistry involved is very important. Many compounds are stable and do not break down like really easily. Because they dissolve easily, they can travel through a bunch of, like I said before, rivers, lakes, even the drinking systems that we have, groundwater, etc., like that. These compounds contain chemical function groups such as uh, carbolic acids and aromatic rings, and then they can also get into animes. So common drug compounds. So these are some compounds that they have found in the water and that can go along or has chemistry behind it. So we already know what ibuprofen is. So basically C13, H18O2. We know what fluoxetine is. So it's C17, H18, F3NO. We know what sulfat max uh, methyloxyl is C10, H11N3O37, and then we know what epacetaminophen is. It's C8H9NO2. So these are just the compounds we show on the right side, and this is all found in Can and Nixel et al. And these are also related to what we're learning now in chemistry, finding different compounds, ionic equations, and net ionic equations, and also involved with our periodic table. Detection methods. So first, we also use different techniques. Well, scientists use different chemistry techniques. They use a thing called HPLC, which is called the high performance liquid uh, chromatography. It basically separates chemicals so scientists can identify them. And then they also use a thing called a mass spectrometer. This technique measures molecular masses and helps identify compounds. These methods can detect chemicals in parts per trillion levels, which is also finding one finding one drop of water in several Olympic-sized swimming pools as well, according to Can and Nexel et al. Present day issues. So today, our contamination is being studied. Scientists found that antibiotics, antidepressants, hormones, and pain relievers in human health have a lot of human health concerns. The biggest concern is that scientists do not fully understand the effects of the long-term exposure. Researchers are also studying effects of aquatic life such as fish and other animals in the water. Roles of experts or chemists. We got chemists. They identify and analyze contaminants. We got pharmacists, which educate the public in proper medication disposal. Then we have toxicologists, which basically they study the health effects of exposure. And then environmental studies monitor our ecosystem and our environment, according to Cordero et al. So some positive social impacts. Scientists can now identify containments and find out what's contaminating the water. They have improved the water treatment, which scientists can now activate carbon filtration and reverse osmosis, which can also remove some of the the things that's contaminating the water. Public awareness. So basically, they're having different programs called drug take back, which helps produce improper disposal. And this is also found in Cordero et al. Some negative impacts. The bacteria can be exposed into the antibiotics. Scientists are studying potential long-term effects. Advanced treatment systems are expensive, which can hurt our ecosystem and our environment. And then some containments can disrupt aquatic ecosystems in our environment, according to Can and Nacelle et al. Future of drugs and drinking water. Nanotechnology. Small materials that can capture contaminants. Then we have advanced filtration, which new membrane systems can remove more pollutants. Green chemistry is basically scientists are designing drugs that break down more easily after they are used. And then stronger regulations is having the governments require more stricter monitoring and testing ideas. Conclusions. So for our conclusion, contamination in drinking water is a significant issue that's going on and has a lot of chemistry behind it. We learned how drugs enter water systems, then the chemistry behind it, contamination, and how scientists detect these compounds and are trying to find good ways to make our ecosystem and our environment healthy. Although challenges remain and some studies need to be studied even more, they provide enough solutions through better detection methods and treatments and technologies and public education. And these are my references. Thank you for listening.